moons, you can keep the planet.
The biggest eruptions. The coldest temperatures. And the largest oceans in the solar system. They're all on moons.
There are moons with ice volcanoes. There are moons with lakes of methane and methane rainfall, smog, clouds. Moons that are so volcanically active that they keep remaking their surface. Moons with all kinds of plumes shooting off into space. Really a much wider range of environments than we ever could have imagined.
He barely even tapped you.
Often when I'm describing to the general public, or even to my fellow scientists, these moons of Saturn and Jupiter, I call them worlds, because they really do have the complexity and mystery of the whole world.
While the walls are not that
Jupiter
thick.
and Saturn have over 60 moons each. These giant gas planets and their moons are like mini solar systems. And each moon has a distinct personality. Iapetus, a two-toned moon in black and white. Titan, with a dense orange atmosphere.
What is that thing? I know what it's called.
And icy Enceladus, blasting ice geysers 200 miles into space. Each moon is unique, but they all have one thing in common. All moons are natural satellites held in place by gravity. But moons do more than just go around planets. They help stabilize the planets in their orbits and keep the machinery of the solar system running smoothly.
The diversity of moons is an interesting combination of predictable laws of science and then complete randomness of just things smashing together and the chips kind of falling where they did in a way that you could never predict.
Planets and moons begin the same way. Once a star turns on, there's a lot of dust and gas left over. Slowly, the dust particles clump together, forming rocks. The rocks smash into each other and form boulders. Slowly, the objects get bigger and bigger. The process is called accretion.
One can think of it as forming a snowball and rolling it down a hill. As it rolls down the hill, it collects and gathers up yet more snow, which makes it roll faster and harder. And so that process of runaway accretion actually happens in the formation of the planets and in the formation of moons as well.
It sounds simple enough, but nobody knew for sure how it worked. Until 2003. On the International Space Station, astronaut Don Pettit was experimenting in zero gravity. He put grains of salt and sugar inside a plastic baggie. Instead of floating apart, they began to clump together.
Salt and sugar?
This is how both planets and moons build up.
So remember we talked
But
about
instead of
how
taking shape around stars,
the moons form,
most
the
big
planets
moons
form.
take
That really
shape
worked
around planets.
in space. That's when you videotaped it.
If the same process makes them all, what makes all of them so different from each other? Take two of Jupiter's moons, Callisto and Ganymede. two very different moons, each born from the same debris when Jupiter was still young.
What about Europa?
Ganymede formed close to Jupiter, where there was lots of debris. Because there was so much material, it came together quickly, at about 10,000 years. And it was hot.
You call that quickly.
The heat separated the ice from the rock. You can still see it in Ganymede's distinct landscape.
The primary factor that affects why moons are the way they are today is energy. How much energy was put into them as heat during accretion, and how much energy has been lost. All of those factors go into telling us why moons behave the way they do and why they look the way they do today.
Callisto's surface tells a different story. It formed much farther out, where there was less debris and less heat. It took longer and cooled faster. Unlike Ganymede, Callisto's surface is uniform. Rock and ice never separated. Where a moon forms can also mean the difference between survival and destruction. Get too close, and the planet's gravity will rip a moon to shreds. Scientists believe this is what happened to many moons when Jupiter was young.
That kind of says that our moon turned into a meteorite.
And it's very likely that Jupiter had an entire conveyor belt of large moons that were running to form, only to be swallowed up by the sun in itself. The large moons we see today are only the last ones that were able to stabilize right at the end of that process, stop their death spiral, and survive into the position we see today.
But Jupiter keeps trying to eat them. The gravity of the giant planet reaches out and pulls hard on the orbiting moons.
Oh, yeah, you are.
Asha, are you guys making volcanoes?
Huh?
Are you guys making volcanoes?
They already did. It was so
It
messy.
transforms them from lifeless balls of rock into strange and dramatic worlds. Jupiter is the largest planet in our solar system. It has 63 moons. The four largest are called the Galilean moons, named after the astronomer Galileo, who discovered them in 1610. They show how gravity controls both what moons look like and how they behave. The first of the Galilean moons, Io, orbits closest to the planet, just 260,000 miles above Jupiter. That's about the same distance as our moon is from Earth. But unlike our moon, the surface of Io has no impact craters. Scientists realized that meant the surface was new. But how could that be?
Every time you look at Io with a spacecraft or even with a telescope, it's a little bit different. So the geology on Io changes like the weather on other planets. It's that active.
When NASA first sent probes to fly past Io, they were shocked. They saw dozens of active volcanoes. This is footage of an erupting supervolcano on Io, blasting 200 miles into space. Everyone had the same question. How could there be active volcanoes on a moon? The answer was simple: gravity. Jupiter's gravity is so huge that it reaches out and crunches the moon. And it's not just Jupiter's gravity pulling on Io. Other nearby moons also pull on it as they pass by. So, the core of the moon is being worked back and forth all the time. It's called tidal friction and generates extreme heat in Io's core.
Almost like bending a wire coat hanger until it breaks. You feel the inside of the coat hanger there. It feels rather warm. That tidal friction, that internal friction, heats the interior of Io until it's become actually one of the most volcanically active worlds in the solar system.
The constant pushing and pulling generates temperatures thousands of degrees high inside Io. It blasts out in gigantic eruptions of lava.
Io is the prime example of tidal forces and gravitational interactions in the solar system. It is constantly being pulled by Jupiter, and it's constantly getting pulled by the other moons as well. And so, as a result, there's a tremendous amount of heat created.
The floods of erupting lava constantly resurface Io, which is why there are no visible impact craters on this moon. Gravity also heats Io's neighbor, Europa. Europa's orbit is farther away from Jupiter, so it's much colder. Instead of lava, the surface of Europa is ice. The lowest recorded temperature in Antarctica is minus 128 degrees. Europa's surface is twice as cold. But underneath all the ice, there may be an ocean of water heated by the same tidal friction that makes Io volcanic.
Europa has a subsurface ocean, almost certainly, and that subsurface ocean is in contact with the rocky mantle, which provides heat and also provides probably appropriate nutrients to sustain life.
Someday, we'll send a probe to explore beneath the ice on Europa. And maybe we'll discover life forms living there in warm Europan oceans. Out beyond Io and Europa are nearly 60 more moons. They orbit much further away from Jupiter, where the effects of the giant planet's gravity are much weaker. Out here, it's too weak to generate tidal friction and heat the moons. So, these remote worlds are cold and barren. But not featureless. They bear the scars of countless collisions, and scientists believe it was collisions that created the most extraordinary moon system of them all. The planet with the most unusual moon system is Saturn. It's spread out over more than 200,000 miles. Technically, there are more than 1 billion moons. That's right, 1 billion moons. And all together, they make up Saturn's rings.
Yeah, if you think about a moon as
A
a
moon
satellite
can be a hunk
orbiting.
of rock or ice, no bigger than a pebble, as long as it orbits a planet. The rings of Saturn are made of countless pieces of rock and ice. They go from the size of a pebble up to the size of a city.
We don't refer to all the ring particles that can get to be as big as 10 or 20 meters across. We don't refer to them as individual moons, but when we find a body that is maybe 1 kilometer or 2 across, then you can start talking about it as a moon or a moonlet.
Saturn's rings are one of the oldest mysteries of astronomy. Where did they come from? To try and find out, NASA sent the Cassini probe on a 12-year mission to study Saturn. its rings,